Rosalind Franklin's contribution to the discovery of DNA's double helix structure is one of science's most compelling stories of triumph and oversight. Often overshadowed by the names Watson and Crick, Franklin's pivotal role in unlocking the secrets of life at a molecular level is now gaining the recognition it deserves. Her precise X-ray diffraction images provided the essential data that led to the revelation of DNA's structure, but for years, her contributions were largely ignored or undervalued in mainstream scientific narratives. Born in 1920 to a prominent British Jewish family, Rosalind Franklin was an exceptionally bright student with a passion for science. She excelled in chemistry at Cambridge University, where she later completed her PhD in physical chemistry. Her expertise in crystallography and X-ray diffraction would later become critical in her groundbreaking work on DNA. After working in Paris for a few years, Franklin returned to London in 1951, where she joined King's College and began her work that would eventually change the course of biology. At King's College, Franklin worked closely with Maurice Wilkins, though their collaboration was often fraught with tension due to a misunderstanding of roles. Nevertheless, it was during this time that Franklin captured photograph 51, the iconic X-ray diffraction image that clearly indicated DNA's double helix structure. This photograph became the foundation of the discovery made by James Watson and Francis Crick, who were racing to understand DNA's architecture. The circumstances under which Watson and Crick gained access to Franklin's data have sparked controversy. Without Franklin's knowledge, Wilkins showed them her X-ray images, giving them the critical insight they needed to construct their DNA model. In 1953, Watson and Crick published their now famous paper in Nature, laying out the double helix structure of DNA. Franklin's data was only mentioned in passing, and her contributions went largely unrecognized in the public eye for years. Franklin's scientific prowess extended beyond DNA. After leaving King's College, she made significant advances in the study of viruses at Birkbeck College. Her meticulous research on the tobacco mosaic virus and polio virus demonstrated her versatility and brilliance in multiple fields of molecular biology. Unfortunately, Franklin's career was cut tragically short. She died of ovarian cancer in 1958 at the age of 37, just 4 years before Watson, Crick and Wilkins were awarded the Nobel Prize for the discovery of DNA's structure. Nobel rules prevent posthumous nominations, so Franklin's name was not included. In recent decades, there has been a concerted effort to bring Rosalind Franklin's contributions into the spotlight. Her story raises important questions about how scientific credit is allocated and how gender dynamics have historically influenced the recognition of women in science. Franklin was not only an outstanding researcher, but also a pioneer for women in a male-dominated field, showing immense dedication and resilience throughout her career. Rosalind Franklin's legacy is not merely tied to her role in the discovery of DNA. Her life and work continue to inspire new generations of scientists, particularly women, to pursue their passions and fight for recognition in a field where credit can often be misappropriated. Today, her name is synonymous with the unsung heroes of science, those whose brilliance may not have been fully acknowledged in their time, but whose contributions fundamentally shape our understanding of the world.